Hello everyone, welcome back to Technologies Discussion channel. For this video, I'd like to continue the discussion on EMC. This video, in more specific, I'm going to concentrate on this standard IEC or EN 61000-3-2. So this is actually known as harmonic. So this video, I'm going to describe firstly what is this standard and how we can actually pass this harmonic current emission compliant. So this will be the objective of this video. This is my email. If you have any question regards on this discussion, please drop me an email. Okay, or if not, I actually prefer you guys to ask me your question through the comment. Before I continue, I'd like to urge you guys to help me by like this video. Guys, help me press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. I have shown you this slide several times for my EMC consideration discussion. This is your duty. Okay, so these are the various EMC tests that you need to execute before you can certify that this product actually passed either the CE or FCC test. So over here, okay, earlier on, previous video, I actually described on this EN 61000-4-11, which is the AC voltage dips, variation, and interrupts. Like I mentioned earlier on, this video, I will concentrate on 61000-3-2, which is harmonics. From here, you can see that these two tests, which I described earlier on, they are actually executed under the AC main. On the other side, you can see that this is another cable, mainly for input and output port. You can see that we actually didn't execute this test, AC voltage dip, variation, and interruption, harmonics, and flicker for the I/O port. We only done all these tests at the AC main port. So guys, if you're keen to know this video, I will put under the description for your reference. What is EN 61000-3-2? Okay, so basically this is just limit for harmonics current emission. So firstly, let me explain what is harmonic. So basically, we have this fundamental frequency. This is the useful frequency for current, for example, for this case here. When we talk about harmonics, which means that for this case here, this is 2 times the fundamental, which means that this is actually the fundamental, which is 2 multiplied by the fundamental frequency. Then you have this so-called harmonics, which is known as the second harmonics. As for third harmonics, is basically 3 times the fundamental. So this is what we know as the third harmonic. So these are all the maximum current emission for the different harmonics for the different class. Later on, I will further describe all these different class for different product, different test case here. But over here, you can see that under the different harmonics, in fact, you have different limit for the harmonic current emission. Okay, so in short, why we need to have this harmonic current emission? So basically, in short, they are mainly limit the disturbance to the mains. Okay, imagine this. You basically connect your DUT, for example, to the mains, AC mains. So basically, they also introduce some disturbance, and this can cause a disrupt under the main, because under the main, a lot of other devices are actually using up the power to power up all the respective power. So hence, we do not want to put a noisy device to upset the mains. So in short, this is the key purpose of harmonic current emission. So in short, under this harmonics, they basically specify the maximum permissible value for the harmonic current, typically from the second harmonic all the way up to 40 harmonics. So in short, again, I'd like to emphasize this 61000-3-2 is mainly for equipment that is actually used up to 16 ampere per phase. Anything more than 60 ampere per phase, you actually need to look at another standard, which is 61000-3-12. So basically, you probably ask, why we need to worry about the current emission under the harmonics? Because nowadays, most of the power supply, we actually use this switch mode power supply. This switch mode power supply, they are non-linear, and therefore they in fact inject a lot of different harmonics current into the electrical distribution system. Okay, so basically this is the main. So basically we need to do this test to ensure that we do not introduce harmonic current emission into the main to disturb the rest of the device that share our main power distribution. Let me further explain on the harmonics. For example, like I mentioned earlier on, this is actually the fundamental, which means that this is actually in fact the most useful current. For example, for this case here, you can see that being the lowest frequency, they also has the longest duty cycle. So this is actually for the fundamental. Next, this will be the third harmonic. Like I mentioned earlier on, this is basically 3 times the fundamental. So basically, they are actually of a higher frequency, and therefore from here you can see that the period, okay, is actually shorter as compared to the fundamental. And this thing go on and on for the higher order of harmonics. So you can imagine that if let's say all this current they actually add up, they become look like a waveform that look like this. So this is totally out of the sinusoidal waveform of the fundamental. This don't look like a sine wave anymore. So this can be a key issue. And all this disturbance under the harmonics can cause some disturbance for the main. So therefore, we need to be very careful when we actually inject our device into the mains. Okay, so like I mentioned earlier on, mainly okay, for this 61000-3-2 is a CE standard. So basically, they limit the harmonic current emission okay, from the electrical and electronics equipment that typically has a current of less than 16 ampere per phase. So in simple terms, they actually limit how much a device can distort the main waveform by drawing non-sinusoidal current. Harmonic current can therefore reduce the efficiency of power distribution, and therefore because of the potential affect the performance of other connected equipment. So therefore we need to comply this standard before we can certify this product actually pass the CE or the FCC certification. These are the electrics equipment that require to comply this harmonic current emission test under 61000-3-2. So in short, any electronics device that is less than 16 ampere per phase, they are required to pass this test. Ideally, for any AC device, in fact, we want them to draw a smooth sine current and also voltage. However, this is only for ideal situation. Nowadays, as I mentioned earlier on, we are using more and more on under this switch mode. And therefore, we have, for example, things like bridge rectifier, capacitor input power supply, etc. All these actually create a lot of harmonics. Again, like I mentioned earlier on, with more and more harmonics add onto the sine wave, this is in fact the fundamental, the green color one. So when you actually add on more and more harmonics, you can see that they in fact become a square wave rather than a sine wave. This become an issue. Okay, because these harmonics, in fact, they can cause extra heating in cables and also transformer. They also will increase the losses, the voltage waveform, in fact, distortion, and the problem with other equipment that actually share the same main. So therefore, we need to have this 61000-3-2 that actually specify the maximum allowable harmonic current. So this is the motivation why we need to have this standard. Let me quickly explain this diagram. So over here, you can see that we have line 1, line 2, line 3, which means that 3 phase. Over here, you can also see that there are in fact 2 standard, 61000-3-2, okay, for any device that actually draw under 16 ampere. While on the other side is basically for device that actually draw more than 16 ampere. So these are all the different so-called current emission reading, okay, for the fundamental and also for the different harmonics. The standard, okay, for under 16 ampere is basically in orange. So these are all the maximum permissible value for the different harmonics. let me bring you through under this harmonic 2. Okay, so under harmonic 2, let's say for this under 16 ampere, okay, for class A device is actually 1.08. So this is actually under the harmonic 2. You can see that the value maximum is around 1.08. Let me bring you another one. Okay, so basically this is the third harmonic, which is 2.3. Okay, so again, we are looking at under 16 ampere. So basically this is actually around 2.3. So basically this is the maximum permissible, okay, for those orange, okay, for this dash 3, dash 2. And the red color is for device that draw higher current, okay, more than 16 ampere per phase. So basically, in short, this is how we actually read. So if anything more than the permissible value, which means that we do not pass this standard. Anything that is less than this permissible value, which means that we actually pass this 61000-3-2 standard. These are the 4 equipment classes. Okay, let me come to B first instead of A. Okay, so under B, these are for portable tools and also certain professional equipment. As for class C, it's mainly for the lighting equipment. For D, it's basically a certain types of equipment. Basically, they will be at the specific power range and they have the characteristics input current. For example, our TV, our PC, and monitor, they actually belongs to class D. Anything that is not within the class B, C, or D, they actually fall under the class A. So basically, in short, different class actually has different maximum harmonic current emission, okay, the permissible value. Okay, so basically, in short, these are for the 4 equipment classes. Coming to my last slide for today's presentation, why we need to do this test 61000-3-2 that is mainly for harmonic current emission. So one of the key reason is because it's part of the regulatory compliant. You need to pass this test before you can sell this product in Europe, for example, for this case here. Hence, it is very important, okay, for us to ensure that any device that we meet, we should not exceed the limit which may not be able to meet the applicable EMC requirement from the Europe. Second, okay, we need to protect the power network. Like I mentioned earlier on, this excessive harmonic current, they in fact can distort the AC supply waveform. And with this, they can also increase the heating and losses in cable, transformer, and also other equipment. Third, okay, so in fact, the extra harmonic current, they in fact can become a interference with other equipment that share the same main. So in short, the harmonic distortion from one device, they can affect another equipment that they are basically sharing the same electrical network. Fourth, this is very important for modern electronic power supplies. Like I mentioned, because of the evolutions of power supply, we are using more bridge rectifier, more bulk capacitor, more switch mode power supply. So in fact, they can draw current in a very short pulse, and hence because of this, they produce quite significant third, fifth, and seventh, or even higher harmonics, which can be an issue. So one of the easiest way to make correction is to use this power factor correction. Basically, this circuit often used to reduce all this harmonic emission. With this, that's all I have for this video. Please help me to like this video and subscribe to this channel. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.